The other reason is that when you start to understand that you have this kind of seesaw system in your body, this autonomic nervous system that takes you from alert and calm to stressed to full-blown panic, it has that capacity, or from sleepy and drowsy to passing out tired. For the listeners that may have heard of EMDR, so eye movement desensitization and reprocessing, this is a therapeutic tool that's used in the clinic to deal with trauma and fear and anxiety, where people move their eyes from side to side, which looks kind of goofy if, when you look at it from the perspective of, well, I'm just sitting still moving my eyes from side to side. That's weird. But that mimics the forward movement of the body. And the body doesn't know the difference between whether or not you're actually moving through a physical environment by walking, or whether or not you're just moving your eyes from side to side. And that underscores the fact that the eyes are the dominant force in driving these states of mind, right? So the fear centers of the brain don't actually know about the movement of my limbs. They know about the movement of my eyes, right?
It's
and
powerful.
So, yeah, it's amazing. And I can't take any credit for EMDR. I think, Francine Shapiro discovered that while taking a walk. She was a therapist. She was taking a walk, I think in the woods behind Palo Alto, where she lived at the time, and realized that some of her anxiety was reduced by the walk. And then, vertical eye movements and keeping her eyes closed didn't have the same effect. And she exported that to the clinic because it's hard to do therapy while people are walking. Walking, you can walk side by side, but it's just not very practical for the typical therapeutic setting of Zoom, or at that time, people met in offices and held therapy sessions. So EMDR is anchored in this idea. And then you get into the ways in which the eyes and vision are important for seeing objects, what direction those objects are moving. And then eventually you got trichromacy, which is most people are, unless they're colorblind, they see colors and this richness of color that conveys a lot of information besides just picking fruit. You always see the textbook examples of how much easier it is to pick out a beautiful red apple compared to the green apples. Actually, a lot of picking out fruit and vegetables is actually by smell. If you look at people in the supermarket, I guess before they had masks on, they would smell things. But color is a very powerful cue for all sorts of health metrics. We can recognize when we're off or not quite right based on subtle variations in skin tone and things. Eye sheen. In any case, the eyes are doing a lot, and a lot more than just vision. Actually, I'll share a brief note about the circadian biology and the sleep wake stuff.
Please.
There's a guy, a really impressive human being. Everyone should check him out. I've never met him in person, but there's a guy named Dan Mancina, who's a professional skateboarder who is blind. And he has retinitis pigmentosa. And I've known Dan for a little while through conversation. I learned about him. He's very impressive. Just check out his stuff. He's doing incredibly inspirational and directly powerful work in advocacy for blind populations. Anyway, he and I were in contact because he was asking about sleep and sleep issues. A lot of people who are blind have issues with sleep because if they've had their eyes removed or replaced for whatever reason, or if they're lacking all the cells in the retina, including the cells that signal time of day, they have sleep issues. But it turns out that for some people who are can't see, they're completely pattern blind, they can still at a subconscious level, the retina can still perceive light coming in and can signal these circadian clocks. And so Chuck Zeisler's lab at Harvard Medical School showed that some, not all blind people, can improve their quality and depth and timing of sleep by viewing light, even though they can't see that light. And so you and I, the same thing happens for you and I. I mentioned Dan because, he and I are in conversations about how to get some of this information out to the what they call the low vision community, or people who are blind. But in any event, I think that most people don't realize that these two little pieces of brain that we call the eyes and retina that are outside our skull are controlling a tremendous number of aspects of our life. So optic flow is powerful. Getting into self-generated optic flow each day, walking or running or biking. Driving doesn't quite have the same effect, but it might, or motorcycle riding, probably dangerous for other reasons. Probably don't want to do that because we could have a discussion about spinal cord injury, but getting morning light is just absolutely powerful. And then of course, nowadays people are walking, looking at their phone. or they're really glued to the screen of their phone while they're out walking or even exercising sometimes. And then what you do is, when you do that, is you short circuit the process of relieving the anxiety that occurs with an optic flow. So, because the eyes are fixated, they're not moving from side to side. And then you ask, well, people have all these sleep issues. There's a lot of depression and sleep issues, and those can be caused by a number of things. But my friend Samar Hattar's lab at National Institutes of Health, and also David Burson at Brown University, have shown that the light that comes from the phone in the middle of the night from about 11 p.m. to 4 a.m. suppresses dopamine release through a pathway involving a brain structure called the habenula, and can lead to memory defects. So now you start piecing together these things that we see in society, like, oh, when I take a run, I feel better, or I'm just exhausted and kind of stressed, and I wake up in the middle of the night and I look at my phone. You can start tacking the vision science to these things that we know are problematic. And what's so cool is that the solutions lie in establishing those connections. When you start realizing what's happening, you can relieve a lot of sleep issues. This is why Dan and I got into that conversation about what he might or might not be doing in terms of visual behavior, or people who are waking up in the middle of the night and they're trying to get back to sleep by looking at their phone. And even though it's got that nighttime setting, they're actively promoting a depressive state to kick in about a day later. And so, there's a lot of links that I think are starting to establish themselves because of, in part because of social media. There's this convergence of information on podcasts and social media, and science is, at least I'm trying to butt my head into that. And Sachin Panda has been contributing a lot, a former colleague of mine from the Salk Institute. Samar Hattar is now on social media. And so these neuroscientists are starting to raise their hands and say, hey, I think I might know what's going on here, and maybe there's something we could do right now in order to alleviate these issues. So now let's talk about what I'm calling critical period 3 of each 24-hour cycle. So this would be the period of time of late evening. So it might be 6 p.m. for some, depending on when you go to sleep, or 7 p.m., extending into the hours in which you decide to get into bed and go to sleep, and then throughout the night. There are a number of things that you're going to want to do, and there are a number of things that you are going to want to avoid doing in order to optimize your sleep. First of all, you're going to want to avoid bright artificial lights of any color. Yes, of any color. We haven't talked a lot about blue blockers, lenses that block blue wavelengths or short wavelengths of light. I don't have anything against blue blockers. In fact, many people find that blue blockers provide them some relief from headache and some eye strain if they wear blue blockers throughout the day and certainly at night, but you don't need them. And even if you do wear them, you will find that if lights are very bright, doesn't matter if it's a blue light, a yellow light, or a red light, those bright lights will wake up your brain and body. They will activate the same mechanisms that were activated early in the day by sunlight. However, and here's the really diabolical twist, I mentioned this earlier, but the diabolical twist in the way that your brain and body respond to light is that early in the day, in the morning hours, you need a lot of bright light, ideally from sunlight, to be very alert and to wake up. But in the evening hours and nighttime hours, it takes very little light, very few photons, in order to wake up your brain and body and to disrupt your circadian clock and disrupt your sleep. So what that means is that once the sun goes down, which of course is going to happen at different times of year in different places on Earth, but once the sun goes down, you would be wise to try and dim the lights in your indoor environment most days, right? I realize some nights you're going to throw a party and have people over. You might not want to dim the lights. Some nights you're going to go out. You might view a lot of bright lights, but most nights of your life, you're going to want to dim the lights in your internal environment. And ideally, the lights that you do use, you would place low in that physical environment. So you would try and not use overhead lights, but rather rely on desk lamps or lights even placed low to the floor, even on the floor. If you are going to use light at night, and most people do, I would encourage you to use as little artificial light as is required to carry out the activities you need to require safely. That could be studying, in which case you might need a little bit more light in order to read or study. If you're watching a television show or you're watching something on your computer, dim that screen way, way down, as dim as possible, while still, of course, being able to view what you need to view. Even better, I should say, ideally, you would use candlelight and or moonlight. Now, some nights the moon is really bright and you actually can use moonlight to go about your usual activities. Moonlight might seem very, very bright, but actually moonlight is fairly low light intensity. And candlelight, which can also seem very bright, actually is very low light intensity. If you're sitting across a table with some candlelight there, and it's a really bright candle, chances are it's only about 3 to 10 lux, which is very, very little light energy compared to, say, an artificial desk lamp or an overhead light, which is going to be in the area of anywhere from 100 to 1,000 lux. I wake up in the morning and I want to reach for my phone, but I know that even if I were to crank up the brightness on that phone screen, it's not bright enough to trigger that cortisol spike and for me to be at my most alert and focused throughout the day and to optimize my sleep at night. So what I do is I get out of bed and I go outside. And if it's a bright, clear day and the sun is low in the sky or the sun is, starting to get overhead, what we call low solar angle, then I know I'm getting outside at the right time. If there's cloud cover and I can't see the sun, I also know I'm doing a good thing because it turns out, especially on cloudy days, you want to get outside and get as much light energy or photons in your eyes. But let's say it's a very clear day and I can see where the sun is. I do not need to stare directly into the sun. If it's very low in the sky, I might do that because it's not going to be very painful to my eyes. However, if the sun is a little bit brighter and a little bit higher in the sky, sometimes it can be painful to look at. So the way to get this sunlight viewing early in the day is to look toward the sun. If it's too bright to look at directly, well, then don't do that. You just look toward it, but not directly at it. It's absolutely fine to blink. In fact, I encourage you to blink whenever you feel the impulse to blink. Never look at any light, sunlight or otherwise, that's so bright that it's painful to look at because you can damage your eyes. But for this morning sunlight viewing, it's best to not wear sunglasses. That's right, to not wear sunglasses, at least for this morning sunlight viewing. It is absolutely fine to wear eyeglasses or contact lenses, so-called corrective lenses. In fact, those will serve you well in this practice or this tool because they will focus the light onto your neural retina and onto those melanopsin intrinsically photosensitive ganglion cells. I think learning how to calm the nervous system is very powerful. And the best way that I know how to do that is based on 2 studies, one published in Nature, one published in Cell Reports recently, showing that physiological size, there's actually a thing in the literature called physiological size, are one of the fastest ways to bring our overall levels of autonomic arousal down. And a physiological sigh is 2 inhales followed by an extended exhale. So it's like, it's not just a deep breath, it's 2 inhales followed by an exhale, okay? And what that does, and this has been shown several times now in humans and other species as well, is it dilates the little sacs of the lungs, and that second inhale dilates them a little bit more, and it pulls a little bit of carbon dioxide out of the bloodstream so that when we exhale, we offload the maximum amount of carbon dioxide, and it perfectly adjusts the ratio of carbon dioxide and oxygen in the bloodstream and lungs. And sometimes it only takes one of these double inhale exhales. Sometimes somebody needs to do 2 or 3. But that's the fastest way to bring the autonomic nervous system down. A lot of people need such a tool because I think we talk a lot about meditation and tools for calm. And, I can go to Esalen for a weekend and get a massage. I'm going to feel very good. But then when I'm thrown back in real life, I need something that's going to work in real time, what I call a real-time tool. And most people don't know how to control their autonomic nervous system because it's complicated. I can't control my liver function. I can eat, that will calm me, but that has complicated, issues with it too if I'm just eating to calm myself. So the diaphragm is the one skeletal muscle organ that was internally, right? We've got obviously skeletal muscles designed to move things. It's a skeletal muscle organ, unlike the spleen, the liver, the heart, etc. It was designed to be moved voluntarily. And these physiological sighs are actually occurring fairly regularly during sleep to adjust our levels of carbon dioxide and oxygen. And there's a recent study showing that in claustrophobia, this is the breathing pattern that people default to try and offload that carbon dioxide. So whereas there are a lot of really interesting breathing techniques, Wim Hof, Brian McKenzie does great work, Patrick McEwen, Laird and Gabby, the tons of people doing really interesting things out there. My lab has been focused on what are the neural circuits that are designed to achieve particular states that happen to impinge on and capture diaphragm function. And so the reason I think breathing is so powerful is that everyone has a diaphragm, and it's the immediate link to the body. A lot's been made of the vagus nerve. The vagus is the path between the body and mind, but the vagus is very slow. The vagus nerve calming is what you experience when you eat a really rich, carbohydrate-rich meal, or you've had a long day and you put your feet up and you're finally relaxing. It takes minutes to hours to kick in. Whereas the diaphragm is real-time control over your brain state. So the brain knows what the body is doing by how fast the diaphragm is moving. It knows its overall activation state. So when you breathe quickly, those 25 or 30 breaths, the brain says, oh, I must be alert. I'm going to start secreting some noradrenaline. And when you breathe slowly, that level of noradrenaline drops down.